All right, calculating the z-score. So we haven't really talked about a lot about what we've been doing with the standard deviation and the mean, so I'm going to do that now. Let's read this question first. The grades on a math midterm at Springer are roughly symmetric with mu, this is the average, equals 68. Okay, so the average is 68, or the mean, and the standard deviation is 4.5. Brandon scored a 71 on the exam. Find the z-score for Brandon's exam grade, round to 2 decimal places. Okay, so we have some numbers here. I'm going to bring this down. Okay, so we can see the numbers. The grades on a math midterm at Springer are roughly symmetric, so I'm going to draw a line through here and keep it on this square. And this guy right here will be our middle point. And that's going to be our average. So 68 is our average. And it says the standard deviation is 4.5. Okay, so what standard deviation means is you're using this chart, okay? And this you can have on tests. You don't have to memorize all this stuff. You can see right here in the middle that this is the average. This is where most people scored, or not most people scored. It's where all the scores center around. One deviation up and below. So that's this entire area right here. That means that there's 34 plus 34% of the people. That's 68%. Okay, that's more than 2/3 of everybody scores within one standard deviation of +1 and -1. So if you look at this math grade, we know the average is 68. So that means that if you take 68 minus 4.5, we get 63.5. And we add 4.5, we would get 72.5. That means that 2/3 of the students, or 68% technically, scored between a 63.5 and a 72.5. So most students got between a D and a C minus. Brandon scored a 71, and the question is, what's his z-score? How close is he to the average compared to all of his other students? So this one, if we were to draw everything in, so we have 68 minus 4.5 would be what is it? She said 63.5, yeah. 63.5 minus 4.5 more, we would get to 59. I'm going to stop at 2 standard deviations. This chart goes down to 3. You can see that, but I'm only going to do 2 for this one. And then 72.5 goes here, 3 and 77. So all I did is I took that average and I took 4.5 and I added it twice. And I subtracted it twice, okay? And we know that 34% come here, 34% come here. I'm using this chart. Once you don't have to memorize everything. 13.5%. And then everyone else is on the outside of here. So we have 68, this is 27, 75, 85. So 15%, or no, less than that actually, 5% of the people. So 2.5% this way and 2.5% that way. A few people did really good on the test. Only 2.5% of the people, over here, got higher than a 77. So it was a really hard test. On the other hand, very few people actually failed the thing. Most people got a D or above. So depending on how you do the test, it could be a test or it could have been a very fair test. These very few students failed. All right, so let's go back to the question and figure out how to answer this particular question. So it says Brandon scored a 71. So the first thing you're going to want to do is find out how far apart 68 and 71 is. So I'm going to do 71 minus 68, and Brandon got 3% or 3 points higher. You take that and you divide that by your deviation, which is 4.5, and we get 0.66667. It says round to the nearest 2 decimal places, so that would be 0.67. 1, 2, and this one would round up to a 7. Sorry, I'm yawning. Early in the morning. All right, and we are correct. So there it goes. Very, very slow. Okay. So just to be clear, we don't need to draw this diagram every single time. I just want to show you how you would have done it with these numbers. You will have to draw one of these, but you can use this to help you. You just have to be able to put the correct numbers down here in the right spot. But this is what we've been working on standard deviation. This is what a deviation is. 1 deviation up, 2 deviations up, 3 deviations up, and so on. All right, so the next question, we have grades on roughly symmetric. So roughly symmetric means that we can use this chart that I was showing you, okay? Sometimes, like, let's say the test was really easy. Well, then the test would be skewed way up here, and more people would have A's and B's and less D's and F's. Or if it was really hard, it would be skewed to the left. So it kind of matters on how hard the test was. But most of these questions will be roughly symmetric, which means that we can use the standard, standard chart. Close, even closer than the last one. And Michael got an 86. So I'm going to go back to the camera. All right, so first thing we're going to do is 86 is our score minus the average. And we're going to divide by our deviation. So 0.5. It says round to 2 decimal places. That would be technically 0.50. But when it says 0 at the end, you don't need to put it. So I'll just put 0.5. There we go. Question 3. It's very slow. I even let the computer run for a little bit before I started this morning. All right, the grades on language midterm at Loyola are roughly symmetric, with deviation of 4. Vanessa got 65, so she did worse than the average. So all of our numbers, the last two, have been above. So we're going to do 65 first. We're going to minus our average, 69, and we get a negative 4. Divide by our deviation, and we get negative 1. That negative is important. And it would be 1.00, but we don't need that because they're zeros. All right, last question. One more grade question at Santa Rita. Average 77, 3.5 is the standard deviation, and Tiffany scored an 80 on the exam. So 80 minus 77. And our deviation is 3.5. Oops, that's plus, not divide. There we go. And what do we get? 0.857. 2 decimal places would be right here. There's a decimal, 1, 2. The 7 is bigger than a 5, so we round our 5 up to a 6. 0.86. And we are done.